So here we're sort of going to tie together everything we know about the unit circle and exact values to solve some of these trigonometric equations. So we'll start off with this one up the top left here. Now, I see this 2 and this square root of 3, and I know that they're involved in an exact value. We've got that square root of 3 divided by 2 exact value. In fact, if I divide both sides of this equation by 2, I see that the sine of x needs to be equal to the square root of 3 divided by 2. Okay, and this is an exact value. If you cast your minds back to the exact values, we know that this occurs when x is equal to 60 degrees. However, I have this domain here which allows x to be anywhere inside of my unit circle. So if I draw my unit circle and I look at where that 60-degree angle sits, it's somewhere out here. Okay, that measures sine across to the y-axis. So the other angle inside of the unit circle that will also give me that same value for sine would be this angle out here. This would be the 120-degree angle. So I'm actually going to end up with two solutions of 60 degrees and 120 degrees. If I take a look at the second question over here, what I see is I want to get cosine by itself. Okay, so if I divide both sides by 4, so cosine squared or cosine of x squared is then equal to 3 over 4. Now I'll take the square root of both sides. So cosine of x can be plus or minus the square root of 3 over 4. Okay, now if I have a look at this in more detail, I can write that as the square root of 3 divided by the square root of 4, which is just the square root of 3 over 2. Okay, so cosine of x here can be the positive or the negative of the square root of 3 over 2. Now, where is it equal to positive square root of 3 over 2? Well, we know as an exact value that happens when x is equal to 30 degrees. However, I'm allowed for it to be the negative version as well, and I'm also allowed anywhere inside of my unit circle. So if I draw out my rough unit circle like so, I've got this 30-degree angle that comes out like that. Now, if I want cosine, I need the symmetry in the x-axis, so it's going to be this angle down here, which will also give me that positive square root of 3 over 2, and that is your 330-degree angle. However, I'm also allowed the negative version, so I could come out here or I could come out down here. So I would be allowed this 150-degree angle or this 210-degree angle as well, because I'm allowed the positive or the negative version. So I get 4 solutions. I get 30 degrees, 150 degrees, 210 degrees, and 330 degrees. We'll do 2 more questions. Okay, so I've got these down here. So if we call this one here question 3, what I can do here is, this one's actually quite a tricky one. I can divide both sides by the cosine of x, and you'll see why in just a moment, because if I divide both sides by the cosine of x, I get myself to this point. However, we know what the sine divided by cosine is. Okay, we know that that is equal to the tangent. So this is my tan of x, and I need my tan of x to be equal to the square root of 3. Now, when is tan of x equal to the square root of 3? Well, that would be when x is equal to 60 degrees. However, once again, this domain allows me to be anywhere inside of my unit circle. So if I draw my unit circle, I've got my 60-degree angle which sits out here like this. Okay, but I use my ASTC, I see that tangent is also positive down in this third quadrant. So what if I had an angle coming 60 degrees down from this x-axis down sort of that way? Okay, then that would be my angle 180 plus 60, so my 240-degree angle as well would also give me the same angle as my 60-degree angle. So I get my 240 degrees in here as well, because tangent is positive in the third quadrant. I can't use this one, and I can't use this one because tangent is negative in both of those. If I have a look at this fourth and final question, Here we're asked when 2 times the sine of 2x is equal to 1. So again, we'll look to get that sine of 2x bit by itself. So I'll divide both sides by 2. So sine of 2x needs to be equal to a half here. Okay, well imagine this question, instead of 2x in here, imagine this was just sine of theta needs to be equal to a half. Then we would say that theta can be 30 degrees, okay? But again, I'm allowed to be anywhere inside of my unit circle. So if I was to draw out my unit circle, I've got my 30-degree angle up here, okay? However, there's also another angle which gives me a positive a half for sine, and that would be this angle out here. So that would be my 150-degree angle. So I would get 2 solutions there. However, the trick to this question is instead of just a theta, I've actually got 2x here. So I need 2x to be 30 degrees, or I need 2x to be 150 degrees. So if I solve those equations, x needs to be 15 degrees or x needs to be 75 degrees. And you can check that, because if we put x is 15 degrees back into here, we should see that that equation works. So 2 times the sine of, now 2 times 15 is 30, is equal to 1. So 2 times, well, sine of 30 is a half, and that holds. 2 times a half is 1, so 1 is equal to 1. So these are 2 correct solutions. However, are there any more? Well, if I do another lap around this unit circle, so 30 degrees, that's actually the same as 390 degrees, okay? And 150 degrees, well, that would be the same as 510 degrees. So if I was to just do another lap around that unit circle, another 360 degrees. So what if now 2x needed to be equal to 390 degrees? And what if 2x needed to be equal to 510 degrees? Well, at first glance, we look at these and we go, well, they're not inside of my domain. However, what happens once we solve for x? So in this case, we see that x can be equal to 195 degrees, okay, or x is equal to 255 degrees. So once we solve both of these, we see that they are in fact inside of my domain. So I actually get 2 more solutions here. So the way that I kind of like to think of that is, because I've got this 2x on the inside here, it allows me to do an extra lap around my unit circle. So I end up with 1, 2, 3, 4 solutions to this problem.